Hey guys, this is Mr. Yo, and today we're going to talk about Unit 4 reviews. So before you take the test, here are some review guidelines that we're going to do and review these topics. First of all, we have the electron configuration, the Lewis dot structure, ions, and energy of electromagnetic waves. For the energy of electromagnetic waves, I want you guys to look at the PowerPoints that has been provided in your Google Classroom for more details. For the honors, you must do the calculations, which means you have to memorize the two formulas that are going to be provided for you on your test, or it must be memorized for later on. So here it goes. Electron configuration. There are three rules that you must understand. The Aufbau principle, which means filling up the lowest potential energy arrangement of electrons in an atom. This basically means that when you're doing electron configuration, you must make sure that all electrons are filled up before moving to the next level. So, when you move on, without having the highest potential energy, which means when it's being in the excited state, that's when all the electrons are spaced out and they are placed randomly without having any pairs or so. Next is the Pauli exclusion principle, which are two electrons in one orbital with an opposite spin. This basically means that each orbital or each lines or boxes has two electrons, the arrows going up and down. Make sure to have an arrow that's facing up, and if you're doing that, that means that the other orbitals must have the same repetition as well. Another rule is called the Hund's rule, which is equal energy orbital needs one electron before double electrons. This basically means that, as an example, it says it has a three lines or three orbitals or sublevels, where it's asking for you to basically put three electrons. A correct way to do so is that one electrons or each electrons must be placed in each orbitals, like shown below. The top one is the correct answer because it has the three lines or three electrons that's facing up, and there's one electrons in each orbital, unlike the second one, or the example below, has two electrons that are in one orbital with the last orbital being empty. So these are the three important rules that you must understand before going over the electron configurations. So this chart may help you out. So if you want to do any practices and stuff, I want you guys to pause the video and look over this chart and also go over any elements or any elements that you want to do as a practice. So if we move on, the information that must be known. One is that there are four orbitals, which are S, P, D, F. You all know the location if we go back here. The s orbital is located in the first two columns of the periodic table. The p orbital is located in the group 13 through group 18, this whole box. But remember that helium is counted as the s orbital because we can't have one s1 instead of having two electrons in an orbital. So therefore, helium is placed in the s orbital. Next is the d orbital, which is located in the transitional metal, or the middle side of the periodic table. And lastly, the f orbital, which is in the bottom, and it has the 4f and 5f1. There was a misprint on here, so that's why I've changed it into 5f1. And also, when we're on the d orbital, make sure that we start with the 3d, not 4d, as it's shown right next to it, which has 4s, but it must be shown as 3d. The explanation is not going to be given to you because there's a long process. It's more like a college level, and it will bring more confusion to you. So going on, for s orbital, we have two electrons and one orbital. Since we have one orbital that has two electrons, so that means that every time we have an electrons, we will divide it by 2 in order to create the amount of orbitals. For example, the p orbital has 6 electrons. So if we do 6 divided by 2, that gives you 3 orbitals, or 3 lines. For d orbitals, there are 10 electrons, so 10 divided by 2 would give you 5 orbitals. The f orbital has 14 electrons, divided by 2 would give you 7 orbitals. So for the honors class, you must understand the f orbitals, but the regular for for non-honors, you do not have to know the f orbitals, but be sure to make sure that you understand the d orbitals and how to set it up in your electron configuration. Next is silicon. So if we look at silicon in the periodic table, we would get this kind of answer. The left side is the long process of getting the electron configuration, which shows the numbers 22626. This represents the electron configuration, putting into a number format. And the right side is the shortcut way, which is having the noble gas in the beginning, and the rest of the electron configurations. This noble gas can be found in the next before line of the designated element. For example, silicon. The previous noble gas that we get to pass by is the neon. So that's why I put neon and then the rest of the steps. For sodium, we have 1s2, 2s2, 2p6, 3s1, and the shortcut is Ne3s1. All these examples can be shown in the periodic table, so please make sure that you understand how to use the periodic table while you're solving the problem. So copper is this, which contains a d orbital, and cerium, this is the f orbital, so honors class, please do focus on this and have some practice. And then we have the electron orbitals, which means we have boxes with arrows facing up and down. There's many ways to set up the electron orbitals, but this is one of the ways that I've set up. So what I've done was I put the orbitals right next to the 1s instead of putting below because I can't type it that way. But this is how it is. Sodium goes with this, copper, and cerium. You may use a shortcut unless you're prepared to do so. If not, please get used to using the long way to do so. All right, next is the shape of each energy level. We have SPDF. You just need to understand that S is a circle, P, it looks like an infinity sign, D has a 4-petaled flower, and F has 6-petaled flower. Whichever you want to, or if you have your other process or ways to understand this, feel free to do so. But this is how you, these are the pictures that you must memorize for each orbitals. Now, next topic is Lewis dot structure. This is the easiest lesson within this unit, which I've mentioned during class multiple times. What you have to do is you have to find the number of valence electrons, which are electrons that are found that has a max of 8, and also make sure that to have the dots on the top, right, bottom, left. Do not put it diagonally or make it parallel, or not parallel, perpendicular to the dots. So what I mean by that is, so before we go on to the actual examples, here are the periodic table with the first group having 1 valence electron, second group is 2, the 13th group through 18th group has 3, 4, 5, 6, 7, 8. But in order to easily memorize this, what you can do is get rid of the 10th digit in the group section and just remember the ones, which has exactly the same amount as the amount of valence electrons according to it. So here are the examples. Carbon. Carbon, we have 4 valence electron, which is located around here. So we're going to have a carbon with 4 dots surrounding it, but please make sure to put it on the top, right, bottom, or left, or north, south, east, west, if you want to memorize it that way. And then we have xenon. Xenon, we have 8 valence electrons, so we have 1, 2, 3, 4, 5, 6, 7, 8 valence electron. But what I meant by please do not put it perpendicularly means that the dots must not be on top of one another, but right next to it, to a point where it's surrounding or being next to the element itself. So please make sure to do that. Next is ion. Ions, so one is octet rule, which I already mentioned previously, which is having a maximum amount of 8 valence electrons in the outermost electrons. I meant to say its, but I spelled TIS on there. The oxidation state means that total number of electrons that an atom either gains or loses. So that relates with the ions on the following, which is atoms or group of atoms in which the number of electrons is different from the number of protons. So cation and anion. Cation means positive ion. To memorize this, what you can do is the middle T looks like a positive sign, so we would use that as a positive ion. Anion is a negative ion, and you may use whatever process you want to memorize this, but you obviously know that cation is a positive ion, which means that the other one would be the negative. Oxidation means lose electron, and reduction means gaining electron. Feel free to use your own method to memorize these two terms. So here are the examples. We have the F negative 1. So first of all, we have to know where F is located in the electron configuration. So here it is. We have 1s2, 2s2, 2p5. And remember, we have total 9 electrons, which means that it's basically the same amount as the atomic number. So we have 8 electrons. However, we have the negative 1 within as its ion, which we can actually represent as an anion. And also, this would be a reduction because we're gaining electron. Therefore, instead of 9, we have plus 1, which gives you 10 electrons. And that's why instead of 5, I put 6 in here, which this actually provides you the noble gas, which is all the way at the right side of group 18 of your periodic table. Following with the calcium plus 2, we have cation, which is 1s2, 2s2, 2p6, 3s2, 3p6, and 4s2. That gives you a total of 20 electrons. However, since it's a positive 2, which means it's a cation, and also it's an oxidation, that means that we have to subtract 2 from the 20, which would give you 18. And to do so, I have misprinted out this, but there should be 1s2, 2s2, 2p6, 3s2, 3p6. That is the ending point. I've misprinted out, so my apologies. And also, before we move on to the next one, what I want to mention to you guys is the charges. So if we go back to that chart of the valence electron, this one or here on the top, group 1, would be positive 1 because they only have one valence electron. They want to give it away to the valence electrons or the elements that has the highest valence electron, which would be the 7 or 1 minus charge. 2 would give you a positive 2 charge, which try to give away 2 electrons. 3 is positive 3, which means give away 3 electrons. And we have 4, which we were going to skip because this is a 4 positive and 4 minus, or negative, which means that it can either gain 4 electrons or lose 4 electrons, which you do not have to know for now. Group 15 is negative 3, which means it would try to gain 3 more valence electron. Group 16 is gaining 2 more valence electrons, so 2 minus, and 7 is 1 minus charge, which means gaining 1 more valence electron. The 18th, or group 18 or noble gas, does not need a charge because it has full octet rule, which means no charge, 0, neutral. So moving on to the final step or final lesson, the frequency and wavelength of waves. So for this one, the honor students must know how to calculate and use these equations. So please memorize this if possible. For the non-honors, please understand the quantum mechanics perspective. So please go over the scientists and what they have done, what they have contributed for us in the quantum mechanical world. So we have C equals wavelength or lambda V, which means C represents the constant of light wave, which is 3 times 10 to the 8 meters per second. Please remember the unit and the constant number. We have lambda, which equals to wavelength, and that has the meters as a unit. And we have V as in frequency. So in this case, the unit is hertz, or it can be called as 1 over S, or S to the power of negative 1, whichever you like. So it says, what is the wavelength of the wave having a frequency of 3.76 times 10 to the 14? So we have all the information. So we have the constant, we have the frequency. Now we have to find out what the wavelength is. So what I've done was I've rewritten down the equation and I've converted into a way where I can focus on getting into the wavelength. And then I plugged in all the informations, C and V, and that gives you an answer of this. So the units, you may understand how to get that by using dimensional analysis, but do as you wish, but please get the right unit as you solve the question. Next is, what is the frequency of 6.9 times 10 to the negative 13 meters wave? So what I want you guys to do is rewrite the equation again and plug in the information. So please, if you need to pause the video, please pause the video and solve the question. So now here are the answers for that question, and the unit is 1/2. Next, we have the energy of electromagnetic wave. That means E equals Planck's constant times V. So Planck's constant is 6.626 times 10 to the negative 34 joules, not the joules that you're thinking, but is joules, Joules, unit, times second. Or you can say joules per hertz, whichever you like. And E represents the photon energy, which has a unit of joules. V represents the frequency, or hertz, or 1/s and s to the power of -1, which been mentioned before. So here are the questions, and I want you guys to solve it on your own by using the equations. And go ahead and pause the video. So now here are the answers for each of the questions. Please feel free to ask me any questions if you have one while you're solving these questions. And also, please go over the concepts which are given to you in your Google Classroom and the PowerPoints that's provided in there as well. And hope you guys do well on your exam, and good luck. And I'll talk to you guys later.